because it was really approaching a binomial problem from a completely different perspective. So when I read it, it seemed to be okay. You know, a salesman has a 20% probability of making a sale to any customer who enters his department. So I'm thinking, okay, P is going to be 0.2. That's a good start. On a typical day, he will meet with 30 customers, right? And so I thought, okay, that's great. So N is 30. And I was all set for a whole bunch of easy questions, except after that, it got weird because they now want to know what minimum number of sales will he have an 88% certainty of making for any given day. And I'm thinking, wait a minute, that number there is a probability. And they're actually asking for an X value. And I'm thinking, okay, that's going backwards. In other words, it's almost like an inverse normal. It's kind of like an inverse PDF. So I thought, okay, great, what to do here? So thinking about it, went to the trusty calculator. I thought, well, I'm going to have to try to work this with a spreadsheet. So here we go. And this is a good opportunity for me to show you some interesting little tricks. All right, first of all, we normally put the N values here, and you know, don't put anything up here. Like, don't put an X or anything. Just go ahead and we'll just say we need a formula, so that'll be equals. And we want to fill in everything from 0 to 30 without having to just do it. You know, just go 0, enter, 1, enter, all that. So here's the quick way to fill in a count like that. What we want is the sequence command, so that's SEQ, parentheses. All right, now you're going to have to put in exactly what I tell you to do. So this will be X and a comma, and another X and a comma. It's like it's just saying we need a sequence to go from one X to another, and then we want the actual numbers that it needs to go from and to. So 0, comma, and 30. And when you hit enter, that's it. That's the numbers 0 through 30, and you didn't have to type them in all yourself. Okay, so let's go over here. And again, I'm not going to put probability or P here. I think if I need any of these, I'm just going to use the column reference, like the A, the B, the C, or whatever. What I want in this column are all of the binomial PDFs, all the binomial PDFs, and I'm going to do them all at once. And I think we did this before, so this will equal menu, statistics, distributions, and I need the binomial PDF. It's here somewhere. Come on, there it is. All right, so number of trials, I know them to be 30, and the probability of success is 0.2 according to the problem. And for the X value, I just want all of the values for X that we have in column A. So I'm just going to tab in there, and since I don't have a variable reference, I'm just going to put A in there. It doesn't have to be uppercase, it just has to be an A. So tab over to OK and hit enter, and there's all of the binomial PDFs. Well, what I really need finally to answer this question is a running total of those, like we did when we were doing histograms and ogives and we needed cumulative relative frequencies. So I need those things to add up. For example, this spot should be 0.001238, but this spot below it should be the first one here plus the second one, and then the third one should be the sum of the three, running total. All right, so go up here, and you may forget the command for this, but it's cumulative sum, C-U-M-S-U-M, and I just want all of the values in B. So I'm just going to put a B in there and hit enter. All right, and what I want is to find out when we hit the 88th probability. All right, because that's what it said. He needs to achieve an 88% probability. So if we keep looking, it's really somewhere between here and here, because that's 0.87, that's 0.94. So we're really looking at somewhere between 8 and 9. And if you actually look at the question, I can get that back up here, it says, what minimum number of sales will he have an 88 certainty of making for any given day? All right, well, what we need is, it won't be this because you're not quite at 0.88, so it's got to be this. So the answer for it is 9, which was great. I thought, what an elegant way to do the problem. But then I got an email from one of the other teachers, and it was really right after that, and the person said, hey, did you realize that you have an inverse binomial on your calculator and it can answer questions like that? And I thought, no, come on. All right, so I went exploring, and we just need a calculator page. We don't need another page, so calculate. So menu, probability, distributions, and so if we scroll down, oops, let's cancel that. This is a kind of a tricky little emulator, so if we go down, there is your inverse binomial. And I thought, I'll never figure this out. But then I opened it up, cumulative probability, that was what we wanted, that 0.88. Number of trials was 30. I'm thinking, ooh, maybe I can do this. Probability of success is 0.2. That needs to go. And I didn't actually put this display result in matrix form. I just went okay. But then somebody in third period said, that's actually kind of neat. So go ahead and click on that and select it. There it is. And hit tab and hit enter. And remember those two things that I had in the spreadsheet? There they are. So the answer is 9. So very nice. Very nice. Okay. So that was the first thing that we covered, and I'm just going to hit pause for a moment and set up for the second thing, so bear with me here just a second. Only takes a moment. Alright, so what we did on Friday was we looked at binomial simulations, and it's much like any other simulation that we've done in the past, but we just haven't done them lately, so I thought this would be a great time to knock them out. So what I did was I worked with the first one with them so that they could see the process, and then I asked them to do 2 and 3 and turn it in for credit. Anybody who was not present just got a no count on it, so if you want to just practice the first one or one of the other ones, that's fine. It does tell you to pick any 3 of them, but as I looked further, it looked like in number 4 they're asking you to make probability histograms like right here, and I thought, yeah, no, we don't need to do that. So anyway, so let's start out with this first one, and what we're supposed to do is kind of set it up for a simulation, run 10 simulations, and then compare the empirical results, which means the results from your simulation, to the theoretical, which is just doing a binomial PDF or CDF on your calculator, and see how close they get. They may get close, they may not, because 10 simulations isn't very many, and these things do not take long. It sounds like, 10 of these, that's going to be an hour per problem. No, not hardly. Okay? So, the first one, one-time fling. Basically, this is when somebody buys clothes, wears them to a party, and then takes them off, folds them up, gets the sales receipt, walks them back to the store, and gets their money back. So, yeah, I guess people do that, and according to this, 10% of the adults do the one-time fling and don't feel guilty about it. Okay, in a group of 7, all right, so 7 is N, 0.1 is P, so let's just go ahead and get set up for this. So let's see what we've got here. We'll do number 1. So N is going to be 7, P is going to be 0.10 if you must, and let's see what we've got here. We're supposed to find the probability that no one has done a one-time fling. Okay, we can do that. That should be, let's just call this A. That's a binomial. Oops, misspelled that one. Let's go back. So binomial PDF, and that's going to be 7, comma, 0.10, comma, and that was none of them, right? So that would be 0. And I'll give you that answer. That's 0.4783. So that is the theoretical. We're going to put empirical here from our simulation across from it so we can do a comparison. And what was the second one, or part B on this? Let me get this up here. All right, B is at least one person has done a one-time fling. All right, that seems to be a binomial CDF. All right, 7, comma, 0.10, comma. At least one would be from 1 up to 7. So it's basically 1 minus the probability of none. This is 0.5217. And then let's look at the last one here. That's letter C. No more than 2 people have done a one-time fling. That would be 0 or 1 or 2. Now, I had a lot of people that were confused. Like, they're thinking, should that include the 2? Yes, all right. But in other ones, you know, if you have like at most less than 3, let's say, that does not include the 3, because if it's less than 3, it can't include the 3. I had a lot of people that were stumbling over that, but this one's pretty easy. No more than 2 people have done a one-time fling. All right, so that would be binomial CDF. And 7, comma, 0.1, comma, 0 to 2. And that should be quite a high probability, 0.9743. Okay, now let's go ahead and set up for the simulation. We're going to let 0 be assigned to a one-time fling. All right, it's 0.1 probability that any person does this. So if I'm looking at the digits 0 to 9, which I can do because I don't need a lot of detail, I don't need to go to 2 digits, then I just need 10% of those 10 digits to represent somebody with a one-time fling. So I just picked 0. You could pick any number you want. Then we'll just let 1 through 9 not be one-time fling. So 10% are, 90% are not. And the command that we need is random integer. All right, we want the numbers 0 to 9, and we want 7 of them. All right, because this is a group of 7. And so that's how we're going to do the simulation. And it's pretty easy to do. When you go into your calculator, let's get that up here, and we can just use a calculate page. All right, so menu, probability, random, integer. All right, there is a random binomial, but I could not get that to work. Random integer is pretty easy. All right, so we want 0, comma, 9, comma, 7 of them. And all we need to do after we hit enter is count up the number of zeros that we have. So this person is a person that does the one-time fling. All the other ones don't. All right, so what we have here for the first trial is that we have 1. All right, so I'm just going to go ahead and just list these things. Like, this is the first trial, the second, third, fourth, 5th, and then over here 6th, 7th, 8th, 9th, and 10th. And for the first trial, we just did it, we had one person, okay? And from this point on, we don't need to keep doing anything here like going back and calling this back up or cutting and pasting. You just need to hit enter. So for our, for our second trial, we didn't get any. See, no zeros. So out of 7 people, we did not get any. All right, so for this one, we had 0. All right, and you just keep going back and forth like that. You know, keep hitting enter. Here I had 2. So let's record that. So for the third one, we had 2. Trust me, if you're not teaching this, it goes a whole lot quicker. Enter. All right, this one we had 2. All right, so we'll record that. And pretty soon we'll be halfway done, so hit enter. Here we have 1, just this guy right here. So we'll record that. And we'll go on to the 6th one. Okay, we had 1. The 7th one, we had 1. I think I'll double up to make this go a little quicker. And let's see, maybe we can do the last 3 all together. So we have none, 3, and none. All right, I already forgot what that one was, so let's go. So that was none, 3, and none. That's right. So had 0, had 3, and had none, or had 0. Okay, now we just need to go back and answer those questions. All right, this is the probability that none of them were. Remember that? So we had 2 out of 10. So 2 out of 10 is 0.2. Okay, not terribly close, but then again, we're not doing a whole lot of these repetitions. If we did, then we should start to see this number rise until, you know, law of large numbers and everything. All right, this is at least 1. So that's going to be anywhere from 1 on up. So that's 1, 2, 3, 4, 5, 6, 7. Oops, maybe miscounted that. 1, 2, 3, 4, 5, 6, 7. Okay. It should be 8. Did I make a mistake? Oh, this is 3 out of 10. So let's fix that one up. It gets it a little closer. So that would be 0.3. This is 7 out of 10, which is 0.7. And then let's see, no more than 2. Well, we only had 1, this one right here, that was more than 2. So this would be 9 out of 10, or 0.9. So looking at this, these two are fairly close. And then these are a little bit off. But again, you know, we didn't do a whole lot of trials, so we're just going to have to live with a certain amount of variability in our answers. Okay, so that's how you do a simulation.